Okay, so today we're going to be looking at notes 1-5. We're going to be solving absolute value equations and inequalities algebraically. Okay, so the vertical bars around anything on an equation is representing the absolute value. So absolute value, the definition of absolute value is the distance the number is from 0. So some say it's always positive. Yes, it is always positive, but the reason is because it's the distance the number is from 0. Okay? So on number 1, it says the absolute value of x equals 4. We're solving, which means we want to figure out what x equals. So we're trying to figure out what can we take the absolute value of to get 4. So you will have two answers. X equals 4, or x can also equal -4, because if we take the absolute value of -4, we get +4. So on your number line, when you're graphing these, we have 0, -4, +4, and these are just equal to. There's no inequality on these. So you're going to have a closed point. It just equals 4 and equals -4. So closed points. Okay, so number 1 was pretty easy. Now let's look at 2. It says absolute value of 3x plus 4 equals 10. So we know 3x plus 4 has to equal 10, because when we take the absolute value of 10, we get 10. But it can also equal -10, because the absolute value of -10 is 10. So we're going to set up two different equations here. So 3x plus 4 equals 10, or 3x plus 4 can equal -10. Okay, so we're solving both equations. We're going to get two answers. So subtract 4, you're going to have 3x equals 6, so x would equal 2. Or subtract 4, you get 3x equals -14. Divide by 3. And I'm just going to leave that one as a fraction, -14 over 3. We can't reduce it. All right, so we're going to have a 0. We'll have a +2. It's equal to that. And also equal to -14 over 3. Make sure it's a closed point. Okay, so let's look at number 3. Okay, on this one, there's not supposed to be an x right there, so I'm going to just mark it out. Okay, so we have absolute value of 13 minus 5x equals 2. So we know 13 minus 5x has to equal 2 or -2, because when we take the absolute value of either of those numbers, we're going to get 2. So again, I'm going to set up two different equations. So 13 minus 5x can equal 2, or 13 minus 5x can equal -2. So solving two different equations. Subtract 13, so -5x equals -11. So when we divide, we get +11 over 5. The other one, subtract 13, we get -5x equals -15. And then when you divide, you get x equals +3. So we have a 0. Now, since both of these are positive here, you need to figure out which one's going to come first. 5 will go into 11 2 times, so we know it's going to be in between 2 and 3. So 11/5 goes first, and then a 3. So on these are equations that we're solving. So whenever you plot these, you're just plotting a closed point because it includes those two numbers. Okay, so let's look at 4. Now, The ones that we just looked at, all of those had an equal sign. So those were all equations. If you look at number 4, this is an inequality. So this is going to be different. Anytime that you're solving an absolute value inequality, you're going to have to either set up an and or an or statement, depending on what your sign is. So that's less than. That is going to be an and statement. Okay, which is a conjunction. So that's what we need to set up. 3x minus 4 is less than or equal to 8. In order to set up the and statement, I'm going to use the same inequality and then put negative 8 on the other side, because remember we just went over it can be a positive or negative inside before you take the inequality or absolute value. Okay, so we're solving this and statement. First step, add 4. Make sure you do that to all sides. So that's negative 4 is less than or equal to 3x is less than or equal to 12. Then we're dividing by 3. So you should get negative 4 thirds is less than or equal to x is less than or equal to 4. So we'll have an and statement, and we're graphing it, 0, negative 4 thirds, and positive 4. Notice it's equal to both. And remember when we went over conjunctions and statements, they should connect, because it says x is less than or equal to 4, which would be to the left, and greater than or equal to negative 4 thirds. So on your graph there, it should connect. So anytime you're solving an absolute value inequality, you're going to set up an and or an or statement based on whatever your original inequality is. So in this example, it was less than. So a way that I remember is than. On the less than, you're going to have an and statement. Okay, let's take a look at the next page. Okay. So on number 5, absolute value of 6 minus 2x is greater than 14. Okay, so this is how I remember it. When it's greater, it's an or statement that you'll set up. So you'll have 6 minus 2x. Keep your inequality greater than 14, but then set up another one, still keep 6 minus 2x the same, but you'll change the inequality because you're changing that to a negative 14 on the right side. So the most common mistake on this one is forgetting to change that inequality to the opposite of what it was. So we're going to solve, subtract 6. So you have negative 2x is greater than, that would be 8. So when you divide by negative 2, remember, you have to change that when you divide by negative. So that's going to be x is less than negative 4. Need to find the other solution, so subtract 6. So that's negative 2x is less than negative 20. And then divide by a negative 2. So again, we'll have to change that. So that's going to be x is greater than positive 10. So there's your solution there. Remember when we talked about an or statement? An or statement, remember, whenever you graph it, is separate. So we have a 0, a negative 4, and a positive 10. It's not equal to negative 4, so it should be open, and then it's everything less than, so it should be the left. On 10, it's greater than 10, so open and everything to the right. So on your or statements there, they should not connect there. Okay, so let's look at 6. Absolute value of 3 minus x is less than 2. So less than is an and statement. So I'll have 3 minus x is less than 2. But then on your and statements, you will need to put -2 on the other side, but those should match. Those should be facing the same way. So there's our and statement. We will subtract 3 to all sides first. Oh, that doesn't cancel. That's -5 is less than -x is less than -1. So then we'll get rid of the negative. So divide all sides by negative. So that's going to be 5. Since we divided all sides by a -1, we're going to have to change those. So greater than x, greater than, that would be +1. So there's our solution. So when we graph it, we'll have 0, 1, and 5. So it's greater than 1, so open and to the right, and less than 5, so open and to the left. Those should connect because it's an and statement. Now, this one looks different. That's not what you have on your paper. So on number 7, you should have absolute value of 4x minus 11 is greater than or equal to 9. I want you to solve this one on your own. Okay, so take a few minutes to solve it. I will go ahead and give you the answer so that way you know if you did it right or not. You should end up getting x is greater than or equal to 5, or x is less than or equal to 1/2. Okay, so make sure you try that one on your own and make sure that you get those 2 answers there. So anytime you're dealing with an absolute value inequality, you're going to have to set up an and statement or an or statement. Greater is always going to be or. And less than is always going to be and. That's when you have an absolute value inequality. That's how you solve those.